Is the Physicist and Philosopher Hour.
Yeah.
And tonight, Dr. Albers, how are you?
I'm very well, thank you, Wayne. And how are you?
Doing well, thank you. I want to say hello to all of the moderators and everybody else. Thank you for tuning in tonight. So, you and I were just talking about the weather, how it is hot out where you are at, and I was telling you here in Colorado, it is hot and smoky. So lots of weather changes going on, lots of them.
Definitely.
Yeah, it's not like what you and I were, just to give everyone a little background, Claudia and I were talking about when we were growing up. And for myself, when you can say more than a half century, going, oh, wait a minute, I used to think that that was old. Not anymore.
No, when you reach that age, you still feel like a child.
Yeah. Now I'm digging where my aunts and uncles were at, you know? And I had some pretty cool aunt and uncle. I had one particularly, my Aunt Bud and Uncle Dot. They were like really cool. They took me down, I remember, in 1969 down to Berkeley, Claudia. And Berkeley was like where everything was happening. And so I remember actually seeing the flower children.
Wow.
Yeah.
I saw them in movies.
Well, there you go. Yeah. And they were real. And guess what? They had this real big meeting one August, you know, and I don't know, 500,000 people showed up. And so, you know, I'll say one thing for our species, and I'll say this for myself. When my time comes, I'm going to look back and go, I lived through the best time of humanity's creative of music. You know, because I, as a child, I was taught music. I knew how to write music. I knew how to read music, played 3 different musical instruments, all on the classical side. So I have a great appreciation for music. And, you know, when you think what they call today classic rock and roll, those guys, for the most part, all learned about music in school. You know, and anyway, so they're now, it sounds really good.
When I just want to tell you that my classical education all happened when I was very young. So I learned to play the piano when I was 5. I was reading music before I was reading, you know, in Portuguese because but I didn't carry on with it. You know, I went on
you did not?
to study the sciences, and I did ballet when I was 5, 6, and 7.
I could see that. I can see that.
Yeah.
So that's interesting because, you know, they know gifted children who have a propensity for the sciences, for mathematics, for music. Music is mathematics.
It is.
Yeah.
And it was amazing that it was so easy for me to learn to read music. But that made it easy for me to learn to read, because when my mom didn't teach me to read, she taught me letters. But when I started in grade 1, I was reading the famous 5 books immediately. That the much older children were reading. I started on those.
Interesting.
No baby books for me.
So, Dickens. Did you ever read Dickens? Okay.
Yeah, it was Enid Blyton. It was an English author, but it was translated into Portuguese, and that's what I started reading. And they had very few pictures. It was just mainly words on a page. And, you know, a 6-year-old doesn't usually read books like that. But that's what I like.
I know adults that don't read unless they got pictures. You know, but it's so true. And as you and I were talking, I was just reminiscing, you know, the 2 great classics that I remember, particularly with Dickens, is Great Expectations. You know, I don't know, for some reason I got really lost into the character of Pip. And that's why they knew I was gifted as a child, because I would literally get immersed into these characters. And then, of course, The Tale of Two Cities, which is, you know, again, I think a great snapshot of what humanity was at that time. So That is very interesting. You see, this is why we call it the Physicist and Philosopher Hour.
Yes.
Because how much would you say that classical literature helped you in your formative years?
Well, I have read Dickens, quite a few of his books, but when I was younger, I actually started with Jules Verne. You know, I had a scientific inkling. I just, tended that way from the beginning. I read all of Jules Verne's books, every single one.
Did you read Stranger in a Strange Land?
I'm not sure because I read them in Portuguese, but I know I had the whole collection.
Okay. No, that wasn't Jules Verne. Who wrote Stranger in a Strange Land? I'm trying to think. I'm not
sure, but it was like Journey to the Center of the World.
Okay. Yeah.
And Around the World in 80 Days.
Yes.
And then there's another one about going to the moon.
Yes. And then like The Time Machine.
Yes.
Yes.
Yeah.
It's really interesting.
Yeah.
So I agree with you. Go ahead.
And I read a lot of Portuguese classics that most Portuguese children don't read. My mom used to buy me collections, and I would read the whole collection of very old Portuguese stories. So
did they translate? I guess they did. The Odyssey. Was it translated in Portuguese?
Oh, yes.
The Iliad.
Yeah.
Those, and it's amazing how you think, as I'm sitting here now and I reflect, how much those classical works really did impact us. I mean, it impacted me in more ways than I could probably recognize.
The thing is, it develops your brain because the language is slightly different from current language.
Yes.
And you have to put yourself in that frame of mind in order to properly understand the story. And that just stretches your mind a bit more because our minds are, in a way, like a muscle. The more you use it, the more you stretch it, the better it becomes.
That's what I keep saying. My idea board always grows because I ran out of whiteboards on the other side. but the point is that when I learned that through active imagination and through the propensity, I have an eidetic memory. And so when I want to focus in on something, it becomes like a permanent file. Mm-hmm. The point is that it lays down neurons, pathways, synaptic pathways within the, how should we say, the gray matter.
Yes.
And that's something I've learned that I think will keep us, people young.
Yes, I think so. The more you use it, because the pathways are there when you are born. You just have to learn to use them. And the more you use a pathway, the easier it becomes to be used. Your brain just gets used to using that pathway. So that's how you build your framework, by using different pathways and connecting things. And the more connections you make, the better you can make new connections, but you have to connect them to what you already have. And that's why your memory works. If you don't manage to connect new things to your current framework, you will lose them.
Very interesting. And bringing a point about the brain, as you said, the somatic pathways are already there. There was a person here who was mauled by a bear, and they had crushed their skull. They survived, but what was really interesting was that where the skull had been damaged, the brain, that this person, through what she said was a strictly will, concentrating, reprogrammed other parts of her brain that were not designed to carry, for instance, the movement of balance.
Yes.
Yeah.
Yeah, that can be done. You can reprogram other parts of your brain to perform those functions. Because we don't use much of our brain anyway. There's a lot of it that's not being used. So.
Well, I still say one day we shall, expand it. So, Dr. Albers, what a week.
Yes, indeed.
Yes, lots going on. Mm-hmm. I wanted to bring up in a discussion, I wanted to show you this. So let me go over here because I am seeing something that, quite frankly, I think is alarming to me, and I wanted to get your take on it. Mm-hmm. So here we are. We're now going into 5 days, another stretch of no sunspot activity. 2018, we've had already 92 days of no sunspots at all. Mm-hmm. And Claudia, this is what's really alarming me. I'm going to go to Discover, and let me pull this up. Claudia, this is what I am really getting concerned about is two things. We look at density and the speed coming off of the sun. Let me go back over here and maybe hit ACE. It's probably ACE would be the better one. Yeah. This is what's concerning me, Claudia.
Yeah, we have low speed, but I would say that is to be expected because don't forget, I've already I've written many times about the fact that the SDO images show that the sun is emitting less and less light. It has been doing so for years. Eventually, that weakness would impact the solar wind speed. Basically, the sun's not strong enough to have a strong particle ejection to produce the solar wind.
And look at the temperature. I mean,
yes, the temperature will go with that because the temperature comes from the kinetic energy of the particles. So the particles have low speed, have low kinetic energy.
So this is, I think as my wife as a nurse would put this, if this was a patient, they would be almost in hypothermia because the temperature of the sun, as you can see, we're getting into parts of the scale that's not even on the scale anymore.
Yeah, that would go along with the low speed. What troubles me, though, is what you discovered about that data from the ACE data.
Yes, ma'am.
It seems to indicate that we're getting higher density at the magnetopoles that then has been reported.
Let me pull up that paper that you wrote, all right?
Yeah.
Okay, let me get that because I do have it queued up. So,
and in fact, they are actively trying to hide that fact from the way they are setting up the scales.
So here is the paper. This is your the one you just sent me.
Yeah.
So walk us through this because...
Okay, so they actually started with you because you noticed those dark colors in those images. So I looked at your video and I started looking at the data. And I first explained where the ACE spacecraft is. It's at the L1 position, which means that it's always between the sun and the Earth. So it's in front of the Earth as CMEs come in. That's why it's an early warning system for CME impacting the magnetosphere.
Yeah, we have what, about an hour?
Yeah, it's about an hour.
Yeah, okay.
And this is one of the images that you saw. As you can see, you notice the dark purple.
Yes,
and
ma'am.
if you compare that with an image like you have on the right-hand side there, which is from May 31st, you see the dark blue. And if you compare the two, you say, oh, but now the density is much, much lower on the sun side of the magnetosphere. Okay, that's what it looks like. But when you look at the scale, that's not what is happening. Because if you look at the scale, the minimum value ends with a 4.
Yes.
And the one on the right-hand side ends with a 1, so it's lower. So you have a lower density assigned a blue color that's, further away from what we would logically think should be a darker color, should be assigned to a lower density. But that's not what's occurring here at all. It's the opposite.
The opposite?
It's the opposite. So on the right-hand side, that dark blue means it's a lower density than what the right-hand side purple color means.
Okay.
That's what they're doing in these diagrams, because what they do, and they set it for each frame.
Right.
The simulation takes the whole region into account, the whole region under simulation, and determines what's the highest density that we're likely to get and what's the lowest density. Sets the highest as the maximum on the scale, so that would be on the red part. And as you can see on the one on the left-hand side, it's 0.01704. That's the highest. And the lowest is 0.00004. So that would be the lowest density that you would expect in that image. And so then it assigns the colors according to, the lowest color goes to the lowest density, and one of the red colors goes to the highest density. The same thing is happening with the image on the right-hand side. But they assign the dark blue, the purple, to a higher density than the minimum density on the right-hand side. And they do the same thing with the red. You see that the maximum on the left-hand side, the one with the purple, is 0.017. Yeah. And on the right, it's 0.1198. So the maximum on the right is much higher than the maximum on the left image, the one with the purple, is higher than the maximum on the right image, the one with just the blues.
So what are we seeing then? Is this an intensification or a reduction in the solar wind?
Okay, so what we actually, these diagrams are designed to tell you where the magnetopause is.
Yes.
So they take all the variations and they determine where the highest is, and they know where the magnetopause should be. So that gives them where to draw that white line where the magnetopause is. Sometimes we have higher density coming from the night side, like we do in the right image.
Yeah.
Okay. So we have some red there. But that red is assigned to a density that's lower than the highest density in the image with the purple. So you actually have to look at the scales to be able to compare. Now, in these two images, it initially looks like if you have a wider variation of density occurring, that they would assign more colors to that wider variation. Okay, so you go to a deeper red and you go down to a deeper purple because you have a wider variation. That's what it looks like initially. That may be logical to do that.
Mm-hmm.
Okay, but you still have to realize that you cannot directly compare. You have to look at the minimum and the maximum on the scale at each image. But then if we move down, we're going to compare the one that's on the left-hand side with another one from June 30th. So here on the left-hand side, we have one from June 30th.
Right.
And on the left-hand side, we have that one that we had before on the left in the last image. So that's the June 6th image. Now, you see that we have the same sort of colors in both.
Yes.
Okay. But the variation in the one on the left is from 0 to 0.00761. So that's a variation of 0.00761. Notice there are two zeros after the decimal.
Yes.
And the one on the right-hand side, it's a variation from, like the one we saw, 0.00004 to 0.01704. Notice there's only 1 zero after the decimal. So this is a much higher variation, and yet the same colors are being used.
What the hell's going on here?
Exactly. And in fact, so they used exactly the same colors. They did not go back to just the dark blue and, the reds like we had in the image on the right-hand side. They didn't go back. So that's not what they're doing. And if you actually look, there are actually deeper reds in the image on the left-hand side.
Right
There's
here,
a deeper red for maximum than on the image on the left. And what would that mean? You would look at the magnetopause and you would say, well, I see more red in the left image, so we must have a higher density at the magnetopause there. But it's the reverse, Wayne, because the maximum for the left image is much lower than the maximum for the right image. So you actually have a much higher density at the magnetopause on the right image than on the left image. So it's like they're doing this on purpose. They're reversing things so that when you have a higher density than normal, it looks like it's lower.
This is big. I mean, here they completely zeroed it out. So help us translate then, what is this saying? Is it that my intuition when I saw this, that this was alarming because it started in, as I showed in the video, 1st of June and has intensified. What are we seeing actually taking place? Is this a weakening sun? Is this a hotter sun? What is it?
I'll explain to you what it is, but it seems to me that they actually introduced this deeper purple color on purpose in order to hide the fact that there's higher density coming from the sun.
Wow.
So we're getting lower speed and higher density.
What would cause that?
And I'll explain that.
Okay.
Basically,
I'm just going to take
is going into a red giant phase because it's weaker. Its gravitational attraction on its own matter is now weaker. So it's letting go of its outer layer, just like stars when they go into the red giant phase. It's weaker, so the solar wind is weaker, which means it will be coming out at a lower speed. But because it's just releasing its plasma, there's more particles in the solar wind. So the density is increasing.
So as I'm hearing this, if we're getting denser particles, that can't be good for you and I and other living things.
No.
Okay. All right. Not that I'm going to freak out, but I'm going, well,
yeah, this is
ain't good.
What is occurring. And they actively trying to hide this with this reversal, this counterintuitive use of the color to the scale.
Claudia, I completely missed this. I mean, I caught the variation. I got that, but I completely looked. They're
actively trying to fool people into thinking that when you have a high density, you actually have a lower density.
What the hell?
Yeah. And you can see that even more in the solar wind diagrams, the solar wind speed diagrams. They're doing exactly the same.
And they call us paranoid. Okay. So
what do you expect? They're trying to hide the stuff from us. They've been doing it for ages. So look at the solar wind diagrams. So again, we have the density scale on the right-hand side. Now, if you look at these two diagrams, you would look at the red at the magnetopause, and you would think that the density is much higher in the top image than in the lower image, wouldn't you?
Yes, absolutely.
Exactly, you would. But that's because they've reversed things. Now, look at the maximum on the scale at the top image. It's 1.330.
Correct.
They assigned this red color to that density. Look what it is on the bottom image. It's 1.97. It's much higher.
What the hell?
They assigned an orangey red to that density.
You see, this is what I was looking at it today, and I'm looking at it and I'm going, this isn't making sense to me.
Exactly. They've done this to fool you. And look what's happened with the lower one. The minimum density on the scale for the top image is minus 0.645.
Look at this.
And they assigned a purple to it. And in the lower image, the minimum is minus 0.90, and they didn't assign a purple. They only assigned a dark blue to that.
Claudia, this is, folks, I mean, I can't see what's going on in the chat room, and to the rest that will see this on the replay, Claudia, this is freaking groundbreaking. I mean, you have just uncovered, and listen, I would not have known this. Only obviously a trained physicist would see this. This, I would say I could get alarmed as to what they're trying to cover up here.
Exactly. They're definitely covering something up. It's obvious.
Yes.
And they're doing this all the time. For wider variation, they assign less colors. For smaller variation, they assign more colors.
This is like
this all the time. They set the simulation to do this.
This is bullshit. I mean, I'm just going to be candid with you. This is nonsense because, this is like playing 3-card Monte. This is nonsense. I mean, there is something going on with our sun. The instrumentation is saying it, but they have you just showed what they have done. Mm-hmm. So what is this? Okay, we'll continue.
You see, but from what I know regarding what the stellar cores are doing, which is weakening the sun, which is lowering its gravity. I hadn't thought of this before. When I thought about it, I realized what's happening is our sun is actually, in a way, turning into a red giant. It's expanding in size. It's losing its outer layer. So this outer layer is going out the solar wind into the solar system. So all the planets are immersed in more particles.
So we're going to continue on. And what got me was the theory that you have advanced. I swear that to me, this is what I am looking at as a potential signature of a stellar core, our magnetopause reacting. That's
what it looks like, but it's not actually, Wayne, because that purple color is not as low a density as you have in the lower image.
Yes.
They are fooling you into thinking that.
Yeah. Yeah.
And it's all about hiding the fact that there's higher density at the magnetopause. What would this do? This would increase the ionization of our atmosphere. It's already super ionized because of the stellar cores interacting with our atmosphere. And I'm writing another article with evidence that they are actually interacting in our atmosphere. At least stellar core debris is, small amounts. And so our ionosphere is being ionized to such a degree. And what would that do? That will cause intense lightning storms. That will create currents on the surface that will cause power surges, that will possibly create more earthquake activity. All of this, it just, so many things are happening that are making matters worse for our planet. And this is another one of them.
Well, this is a warning sign. So as we continue on in here, I don't know if that's...
Yeah, basically this is what I explained, that with the sun getting weaker, we'd expect it to basically start turning into a bit of a red giant, losing its outer layer of plasma, and therefore we would get more plasma coming our way, impacting the magnetosphere, but at lower speed because it's weaker. It's no longer able to reject particles at the speed it was able to do before.
I want to go, because I think that this is part of also what's taking place. When I read this article here, I'm thinking to myself, well, if what we're seeing happening to our sun as it begins to, I think it's changing in its structure and its composition, that we would see events like this. And this one is where this was in Thailand?
Yeah, this was the latest one that occurred in Thailand, because you see, whatever's happening with the sun is happening with the earth as well, because these objects are attracted to energy. And the sun is huge, yes, but it generates energy, and so does the earth. The earth is an active planet. It generates energy in its core. The stellar cores are attracted to that energy. And once they come to an object that is generating energy in its core, they become energy bound to it. In other words, they come here, they start absorbing energy, and they don't leave. They stay there. They stay. The ones that have gone to the sun stay with the sun. The ones that have come to the planets in the solar system will stay with those planets. So as the sun is losing energy, the earth is also losing energy to these objects. And the energy is associated to the gravity. They are low gravity objects, but they come very close to the earth. So they come closer than the moon, so they create tidal forces, and they fall tides like the moon does, but they're much more dramatic. That's why you get this sharp change in the sea level. It's basically a tide, but it's much more dramatic than what is produced by the moon, because the objects come much closer than the moon to the earth.
So if we're having a action, right, with the earth in one point, where is the opposite reaction of the result of it? Is that with the thought that I had come that the earth is expanding, and it's actually expanding?
Well, the earth is expanding. That's causing the fissuring and the sinkholes. But this is another effect. This is a direct gravitational effect of an object that exerts a low gravitational force, but it's tidal. So it's very strong right below the object. This is illustrated by this diagram here. So if you have a stellar core debris, so it's a small one, very close to the atmosphere or even within the atmosphere, it will pull the ocean towards it. So the ocean will pile up right underneath it. And then some land, some coastline adjacent to where the ocean is piling up will have the reverse effect, will have a low sea level.
Claudia, I just read a story last week of events that are happening now in the South Pacific and the Atlantic going down to Antarctica, of more stories of rogue waves. I mean, now we're talking 200 feet rogue waves. This would correspond to such a reaction to that.
Exactly, it would. Because these objects may stay stationary for a while, but then they will move across the surface of the earth. And so the wave would follow them.
Wow.
This piling of the ocean underneath them.
So the preponderance of the evidence as we continue to go forward here, the one that we saw from ACE, that we saw on the 3 different simulation models, and there's a number of them that I'm tracking that I want to get your opinion on, because we're seeing the magnetic forces on the sun becoming much more compressed, Claudia, and where it's vacating the polar cap, the polar regions. And I'll show you that. But this, it's like there is a continuing cascading effect that's taking place here now.
That's right, and you will definitely see increasing effects, and this will pull on the magma inside the earth as well. This is one of the reasons why you will have these volcanic eruptions. But mainly by drawing energy from the core of the earth, there's simply more energy coming out through all the layers. That's the same as stoking a fire at the core of the earth. What happens when you stoke the fire? You have more heat coming out.
Yes.
So basically the core of the earth heats up, and all the layers above it heat up as well. So you have the magma expanding and seeking to come out. So then you're going to get volcanic eruptions, more and more volcanic eruptions. And if a pathway is found to the surface, the volcanic eruption is not likely to ever end. It will just keep on going. That's what we see happening in Hawaii.
Yeah. In fact, I read a story today that the museum, it's about to go, folks. It's fallen into the crater. Wow. And what I was quite surprised about is that the crater now extends 1,500 feet beyond its lowest point that they've ever measured.
Wow.
So something's going on over there, Claudia. I mean, something serious is going on. I think as one volcanologist was interviewed today, they asked him, questions. And you know what he did? He looked at him and he said, I don't know. Nobody knows. We don't even know what we're seeing.
Yeah, the thing is, people have not been allowed to look at the evidence for what is really happening at the sun. It's taboo for most scientists. They will not even look there. If they look, they will shut their eyes because they know what will happen to them. They will either die or their careers will end.
It's like being excommunicated from the church.
Exactly.
Out of here.
It is exactly like that, Wayne. That's a good way of putting it.
Well, that's what it is.
Basically, they have turned science into a religion. It's more of a religion. It has its priests, which are the scientists that toe the line with NASA. And they stick to the story that NASA tells them. We don't look anywhere else. We will say anything but tell people the truth. I think you've seen my article on Oumuamua, where the astronomers are now saying that, Kepler's laws are violated by comets all the time. Basically, that's what they're saying, which is absolutely ridiculous. No comet ever violates Kepler's laws. And that they would even go there baffles my mind. And they saying, even though there's no trail detected, that this object is outgassing. Well, if it's outgassing, the gas is gravitationally bound to the object. And then there is no way you're going to get a rocket thrust effect from it. It's impossible. It's physically impossible. This is the same as saying that a volcanic eruption on Earth would cause the Earth to move out of its orbit because there's a lot of sulfur dioxide moving into the atmosphere from the volcano. This is basically what they are saying. It's absolutely ridiculous that astronomers that have been trained in physics have sunk down so low, Wayne.
And listen, I'm right there with you. You know what I think happened on this one from a layman's and a philosopher point?
Yeah.
It scared the crap out of them. They didn't know what this was. It did not comply to, as you said. And when I think about how science is today, you could almost classify it as a cult that goes back millennia ago. They certainly seem to have the names they keep resurrecting on these things. But anyway.
Yeah, in a way, I feel sorry for them, Wayne, because, they cannot tell us the truth.
Yeah.
And so, they left with being able to just tell us fairy stories.
So, Claudia, tell people why the orbit was so extraordinary, how it came in.
This object is in a hyperbolic orbit. So it's an extreme orbit. It hasn't been captured by the sun. All that the sun did was cause it to turn as it moved around it. And this is what you see. You see the change in direction. It came down towards the sun, it made the turn around it, and it went out in a different direction. But like all objects, it obeys Kepler's laws. So it would have to move at its fastest as it reaches its closest position to the sun. That position is called periapsis. So it will move the fastest, and then as it moves away from the sun, as it obeys Kepler's laws, it will slow down. It's supposed to slow down. Now, this object is, I could tell it's not a normal rocky object because on such an extreme orbit, at least when it was close to the ecliptic plane, it should have developed comet characteristics. According to James McKinney, what he discovered about comets, they are electrical in nature. So they will draw in particles from the sun's nebula clouds. The sun has a planetary nebula around it, and they are made up of positive ions, which comets, when they come in, draw upon. That's where the tail comes from. They draw from these planetary clouds. And this object didn't draw any material, no comet characteristics. So, and an object in a circular orbit does not draw. But this object was clearly not in a circular orbit. It was in a very extreme hyperbolic orbit, so it should have drawn particles if it was a normal rocky object. The fact that it didn't means it's not a normal rocky object. It's not a stellar core either, because if it had been a stellar core, it would have stayed at the sun. It would have stayed energy bound to the sun, or it would have been caught by one of the solar system planets. It was not. So it's not a stellar core. It has normal energy in its particles. So it would obey Kepler's laws. And if it was a normal rocky object, it would have behaved like a comet. It didn't. So that means it's not a normal rocky object, and it accelerated.
That's what I was going to get to. And you know, and I know that that's already been discussed out there with some scientists, but my thought is, when I see this looks to me like an observation. It looks like someone is sending something through to observe our inner solar system and then head on back out. And as you said, it accelerated going back out, right?
Yeah, so it accelerated. Now, if it had been a comet and if it had accelerated on the way out, I would have said it would have been pulled in by an object that's close to the sun, perhaps another star that we may not be seeing. Mm-hmm. But because it wasn't a comet, it's not a rocky object, and it's not a normal or rocky object. The only plausible explanation that I can see is that it's a spacecraft under intelligent control with an engine that caused it to accelerate.
And just a little side note on that, when I think of propulsion systems now, I don't see them as needing propellant as we today look at rocketry, even in space. That I think that they know how, or whatever this was like you were saying. I think it was using the sun as almost like a recharger.
It could have come in. I mean, it could have been drawn into the sun. Maybe they were having engine problems. I don't know. Maybe it recharged at the sun.
That's what I was thinking. Yeah.
And then it just, when it moved away, it accelerated. It may have regained the energy it needed. I don't know, but I don't think it's not a normal rocky object. I don't think it's a natural object. I think the most likely is that it is a spacecraft.
I think I would agree with you.
Mm-hmm.
When you look at these objects, and so much is changing, Claudia, in what we perceive as our solar system. It's like I wrote to you today, the thought was, well, if a planet is in what we would call a predictable orbit around a star, mm-hmm. what could cause, or is it even possible for a planet to break or disengage from the star itself and be swung out into a different orbit?
Well, you see, this is likely to happen with the sun in this case, because the sun, as it loses energy, it loses gravitational influence over its own planets. So what will happen is the planets will drift away from the sun. The sun will expand in size. The sun will lose its outer layers of plasma. Eventually, the planets will just drift out into space.
Would we begin to see that effect, Claudia, by the measurements that they take right up here, right from me where I live in Boulder, that we know that our planet is slowing down. It is, and it's been doing it now for a while.
Well,
no, it's milliseconds. Granted, it's milliseconds, but
it's milliseconds so far. To tell you the truth, we don't actually know, because with the sun simulation system they have in our atmosphere, which completely hides the fact that the sun goes dark or is eclipsed, we cannot even know exactly when night is and when day is. They could do anything they want.
While you said that, now I'm going to inject some philosophy. I am curious. I'm doing research. I'm writing a book, and this came up to me. I think I may give you some evidence of a stellar core in its impact from a biblical perspective. Mm-hmm. And that's Joshua, the 10th chapter, mm-hmm. where the sun stopped for 12 hours. Mm. And what I found interesting, Claudia, was that there are corresponding records in China, in South America, of where they called it in China the longest night. The sun did not come up as it was supposed to. So my question was, could that have been an effect of a stellar core?
I don't think it was a stellar core. Why I tell you that, why I think it wasn't a stellar core, is because I think the stellar cores have not started coming into our solar system. Maybe they started coming in maybe 150, maybe maximum 200 years ago.
Okay.
And the reason why I say that, because the way the sun has declined, especially in the last few years, means that if the stellar cores had been here much longer than that, we'd have no sun left at all.
Ah, it would really have depleted the overall. Okay, all right, that makes good sense.
But it may have been a comet, because we have the comets, as I've written before, are actually one of the ways that star systems form planets. They capture comets, and comets gain matter every time they come in through the inner part of that star system. And so this is one of the ways that planets form. And comets are coming in from outside all the time. They keep saying that comets are part of the solar system. I don't think so. I think they are interplanetary rocky objects that are captured by a star system. And every time they come in, they gain more matter and get larger. And eventually they become captured planets. I believe that's what happened with Venus. I actually got that idea from James McKinney. I fully agree with him. I think that's very logical.
Would that been something that we would have seen in a biblical story of the sun stopping?
Yeah, definitely. That's most likely what occurred, is that a comet came very close to the Earth and grabbed the Earth and stopped its rotation. That's a very, I don't actually know for sure, but that's a strong possibility. Also, I think a comet caused the flood.
I would agree with you on that. That would make sense to me. Mm-hmm. And if you had, and I know people have a perception that comets are small, but they can be planet-sized like Venus, and I agree with you. I think I've done a video on that, but I think you're right that if it came close enough to us, that it would have had a dramatic effect on Earth. Mm. I mean, I bet you, Claudia, that if and I'll look on this, there had to have been probably storms taking place in other parts of this planet that had to be hellacious.
Yeah. I mean, what usually happens is a comet grabs the outer part of the planet. Mm-hmm. So it causes a crustal displacement, basically. The crust moves independently, gets grabbed by the comet, the crust. The core continues to rotate at its own speed. But the outer crust gets grabbed and stops rotating, and then it may move independently. I'm not actually sure what happened. I think that's definitely what happened at the flood. There must have been a crustal displacement. And the water actually came from the comet's tail, because there's a lot of water in comets' tails.
People don't know that, but it is.
Yeah. And
Yeah.
it's actually formed because the comet would get hydrogen and oxygen from the nebula clouds. And then electrons come in from the sun's corona, and they combine with the hydrogen, the oxygen. You get then hydrogen and oxygen with all the electrons in it, so the neutral hydrogen and oxygen, and then you can get a chemical reaction where the hydrogen and the oxygen combine to form water. This is where the water in comets' tails comes from.
Interesting. And I'm gonna look into that. It never occurred to me that something that we already have records of, that would have been an interpretation of a comet. Like I said, Venus coming in. I think that's what we see. The scarring on Mars is the result of that passage. And Claudia, that just makes perfect sense.
Yeah, in fact, the flood is likely to have been caused by Venus, which was the comet then that came in. And it possibly went by Mars first. And it was, that Venus is just slightly larger than Mars, but slightly smaller than the Earth. So the fact that it was larger than Mars would mean that it would win the gravitational war with it. And it would then be able to pull all its oceans and most of its atmosphere off.
And would we have seen that happen, that its first passage, that is, it began to get more into a stabilized orbit, that there was probably another crossing of our planet, Mars, who knows what else is out there with Venus?
Yeah, I don't know, but it's a possibility, because we know that Mars didn't lose its oceans that long a time ago, because we can still clearly see the boundaries where the oceans were. We can see the seabeds very clearly. It hasn't been eroded away, so it couldn't have happened very long ago.
You see, that's another thing they're doing to us, Claudia. I mean, when you study, astronomy, you get this idea that we're looking at billions of years before us. We may have been only be looking at less than 1 million years.
Definitely. I think we may be looking, in the case of Mars losing its ocean, several thousand years.
I can believe that. Just by what we've already seen tonight, what we've discussed, is so much compelling evidence, Claudia. It just piles up.
Yeah, the thing is, science has been turned on its head. It's like it's upside down. When they say there's a black hole there, there's a white hole. When they say this is a star that has died, it's actually a strong young star. This is what I discovered by simply studying the stellar cores and their interaction with the sun. I actually discovered how the universe actually works. And I had to basically relearn everything, because what we're being taught, like I say, is the reverse of what's actually out there. It's just unbelievable, Wayne.
It's crazy.
It is.
That's what it is. It is just literally crazy. And listen, you can no longer say that this is conspiratorial, that this is some kind of crackpot science, fringe pseudoscience. The evidence is showing from the standard instrumentation, the birds that we fly up there, the ones that they get the data from already, is showing, Claudia, something has happened.
Yes. And the fact that they go to extremes to hide things from us, like doing this counterintuitive thing with the colors and the scales, what tells you they're trying to hide something? I mean, if they were open about it, they wouldn't do things like that. It's obviously they're trying to hide something from us.
Well, what you just brought out tonight has changed my perception much, much more when I see now what the games that they're playing. I just wanted to pull up what we have in the telemetry data right here. Again, this is amazing to see what they have done. And it's remarkable, Claudia.
It is. And you see, we always would have to look carefully at the scale in order to figure out what they're actually doing. But this is what I've discovered. when the density goes up, they turn down the color so it looks like it's going down.
Bastards. I mean, it's not fair. I mean, listen, what in life is fair? But I mean, come on, guys, give us a break, right?
In a way, they're telling us that they're hiding something. Because otherwise they wouldn't go to this kind of... It's crazy to do a thing like this. It's illogical.
It's nuts. I'm trying to pull up the one model I wanted you to take a look at. Someone pointed out to me, they said, well, isn't it interesting when they look at these satellites, Enlil, they're going back to the Sumerian gods, which I find remarkable. I'm trying to pull up something here, Claudia, and I'm doing this on the fly, and I have to make sure I'm at the right.
Yeah.
Give me 1 second.
Sometimes difficult to find the one you're exactly looking for. I know.
Yes, it is. And some of these modules they have turned off, and so
I've noticed there are a few that are not there anymore.
Yeah, isn't that odd? Some of them are kind of the ones I think that you specifically would immediately recognize and be able to correlate that data into what we're seeing. Here we go.
Exactly. That's exactly why they would get rid of them. So we don't know what's going on, really.
So this is what I have seen taking place on our sun here. And it's taken, well, it started with the same effect we started seeing in June. And normally this field should be encompassing both the polar regions. But at the polar regions, we now have permanent coronal holes, which you can actually see there. You can actually see them. Yes, you can. And just to show everyone that, what they could look like, this is a great tool.
There's something else I see here. And you see those purple lines? Those are coronal holes as well. And as you can see, the sun is developing, and I've said this before, a permanent coronal hole along the equator.
Well, then this is validating exactly what you're saying.
Yeah.
So I went back to 2016. That's what I'm talking about. This is when I first started learning. Mm-hmm. This is what I learned. Yeah.
That's amazing. You see, you only had a permanent coronal hole at the South Pole. You didn't have a permanent coronal hole at the North Pole.
Nothing. Yep.
You had some coronal holes along the equator, but not nearly as many.
Nope.
Definitely a difference here.
This is the evidence that, and I'll just pull it up for today so everyone can see. This is, Claudia, this is saying something's going on.
Yeah. I've been saying this for many months. So this is...
And you know what I'm seeing? And now that you're here, when you and I are looking at this, this is evidence of a weakening sun.
Yeah, of course.
I mean, the streamer belt is being compressed. Someone said it looked like a, what was it? A toroid? I'm trying to think of the word.
Yeah, it looks toroidal. That's to be expected. But the permanent coronal holes at the North and the South Pole are not normal.
So this is all the evidence, Claudia. Graph after graph, sensor after sensor.
The SDO images clearly tell the tale that the sun is so much weaker, and it weakened right through solar maximum. So this has nothing to do with solar cycle. Basically, the sun is just weakening, independent of the solar cycle. And I've already presented many times the evidence that the magnetic field associated with sunspots decreased right through the solar maximum in the previous solar cycle. So weakening independent of the solar cycle again in the previous. This was in solar cycle 23. We're now in solar cycle 24.
And I can go...
Nothing to do with the solar cycle. The sun is simply dying.
So let me see how far...
Going into a grand solar minimum. This is not a grand solar minimum. A grand solar minimum would mean the sun would recover. The sun is not showing signs that it's doing anything to do with any solar cycle. It's simply dying. it's losing energy.
So, folks, this, Claudia, was the last cycle look at this. This is 2012.
Wow. Look at it.
Look at this, folks.
There
And
was a little bit of a coronal hole at the south already. You can see it was developing then.
Yep.
Very interesting.
And
But
look at
definitely much stronger.
much stronger. And it did exactly what we expected it to do. It should, but what we see today. So that's 2012. That was 6 years ago. Well, yeah, 6 years ago. Claudia, what year is this?
Well, we in 2018. The solar maximum was supposed to be in 2014. So this was 2 years before the solar maximum. And you can see it was stronger. If you look at the LCO images, the sun was stronger in 2012 than it was in 2014 at solar maximum.
Yeah. So, and there's it is today, folks. You can actually see the field lines.
Yeah.
Look how they're much more separated.
Yes, definitely.
There's not nearly the density in the belt that we would expect to see. And Claudia, you're right. It's devoid at the poles. Look at this. Permanent. I don't know. I mean, what do you say to the evidence?
I mean, I've been saying it for many months. Basically, our sun is dying, and it's because of the stellar cores. Because people try to come up with an explanation of why the sun is so weak without ever mentioning the fact that there are stellar cores draining it. The sun doesn't grow weak for no reason. And even the solar cycle that we had before, it would have been caused by something. It may have been an interaction between the sun and another star a couple of light years away, but it was some kind of interaction. The sun does not do things without there being a cause. If there's an effect, there is a cause.
That's my point. That's my point. This is wild, Claudia. Listen, folks, these are the tools. You can go use them yourself. They're right there. I encourage people to do that. Wouldn't you, Claudia, as well? It's at least
definitely. I mean, play around with them. But if there is a scale, please just compare the scales very carefully, because we know they're playing around with the scale, so we don't see what's really there.
Yeah, I mean, folks, I mean that was a ringer for me, and I've been following this data for a very long time. And again, I know people sometimes can't believe that the sun is actually dying. They got the eye, and listen, it's a difficult concept. We've been told all of our lives that science says that our star has got another 5 to 10 billion years in its life cycle. Where we get that, I don't know, because if you start asking the simple question, well, how did you get that data? Where did you get that theory from?
Yeah.
I mean,
it's all based on wrong theories, which the stellar cores have shown us.
Yeah, and I'll tell you.
The sun may have lasted millions of years if it had not been for the stellar core system coming in.
Claudia, I make a prediction that we'll see within the next couple of years, we're going to see more and more of your colleagues beginning to acknowledge that there is something more out there in our solar system that's interacting, that, you know, we know that they're messing with the data.
Yeah, well, I hope so, Wayne. But to tell you the truth, I don't even hope anymore. I know that they know that what happened to me will happen to them. They basically lose their career.
Yeah, that's true. You were, by the way, you were interviewed, weren't you?
I was in an interview with a Russian TV. Yeah, it was.
Yeah. Can you tell us a little bit about that?
Yeah, well, they actually asked me a lot of questions about Planet X, but about aliens. You know, I've written about a few articles on that. So they asked me what I thought about that. I was surprised, but you know, I answered as best as I could. And then it was and then they had me look at my books and point at my books and do some explanations and showing some pictures on the laptop and pointing at them and typing. It was a little bit, you know, the setup takes ages. It's lighting here, lighting there. 3 microphones, 2 cameras.
Did they come into your home and set up for the shoot?
We didn't use our own house. We used a friend's house. They needed colorful walls and so on, which we don't have. So, but yeah, we used a friend's house and they filmed there. But it was a little bit like acting, you know. They had me walk from one place to another, and he would say action, and I walk. And, you know, I haven't done anything like that, so it was interesting.
That was my career for almost 20 years.
It was, hey?
Yeah, that's what I did. I worked more on the post-production side, but yeah. So, well, now, are they going to put this into a documentary? Is that right?
No, what's happening is they're producing a documentary for this Russian TV station.
Okay.
And with all this, we actually thought that maybe we will do another one. But it is about Planet X and so on, and about the Science Channel.
Yeah.
We're thinking of doing another one privately, actually, and telling the story. Because our cameraman thought out the story, you know, of how I got into Planet X and
it's a compelling story. I mean,
yes,
yeah.
It is. So we're thinking of actually, you know, in the near future, doing our own documentary on that.
I think you should. I really do. I remember, well, you know, people know that we go way back, and it was the thing I admired most about when I first met you and introduced was the fact that here was what I called a sanctioned professional. That is a person who went through the discipline, went through the process of writing the thesis, having it by peer review, getting your PhD, doing your continued study, and you come out as one who begins to show that there is something yet out there. And that was just beautiful. And of course, your tale since then has been harrowing, to say the least. And I think it's one that should be told over.
Yeah, thank you, Wayne. It has cost me a lot, as you know.
Yeah, yes.
It cost me my career, and I love teaching my students.
Yeah, well, like I said, we have a consistent classroom now of about 250, 260 people.
Yeah.
And everyone here, you know, we take the red pill. We don't take the blue pill. We take the red pill.
Oh, good. Yes, I see you've got the blue and the red there.
See, yeah, we take the red pill, folks. Don't take the blue pill. No.
Yeah, we want to know the truth. This is what it's all about. It's about the truth.
It is. And that's what we tried to bring here. And, you know, I tell so many people all the time, listen, the advancement of our species is by the exploration of ideas. And if we don't have those who will be bold enough to speak the ideas that are beyond the perceptual understanding of the masses, we would be a regressed species. We'd be living still in the caves, Claudia.
Mm-hmm.
It is
most likely
beautiful minds such as yourself. And when people have no idea what sacrifice means, you know, we get the benefit of having you here weekly, which is to me is a delight and it's an honor, because the day will come where I do believe you're going to become much more recognized in the work in the field that you are developing. So
yeah, thank you, Wayne.
Sure.
And thank you for, you know, having me on your program. And you're just such a good interviewer. You know, you just ask the right questions, and you even bring me the right data.
Well, listen, you know, I consider this a classroom, you know, and I don't want to become the ire of the teacher going, what the heck is this that you turned in? I mean, I've been down that road before, and you know what? It sucks. So I find it delightful because, you know, the way I look at it is whether people agree or disagree, the fact is that they're at least listening and they are considering.
Yes.
Yeah.
I think if they don't agree, that's just fine. They just don't listen.
Yeah. I mean, I love my wife,
No one forces anybody to listen.
Yeah. She loves, biscuit and gravy. I don't. But I love that woman. Don't ever try, that's how I look at it here. It's like, folks, the subject is real. Now, how you want to approach it, now that's up to you, Yeah.
I mean, if people want to take the blue pill, that's their decision as well.
Hey, listen, it's so easy. And remember, you'll wake up and you won't feel a thing.
Right.
Oh, well, my lady, another great episode. Thank you for it's classroom all the way, and I thank you, Claudia, that you take the time to teach us. And I hope everyone else. I mean, I look at the comments here, and I love this audience. I really do, and I say that word as one of great admiration and respect and gratitude. So thank you, audience. You guys make it possible. And they're mesmerized. And, the way I look at it, even if we get 2 thumbs down, that's okay. They listened.
That's right. I mean, if they were here to listen, it's because they actually wanted to hear it.
Yeah, maybe they don't like Metropolitan ice cream. Maybe they just like plain vanilla.
Yeah.
There's nothing wrong with that. Well, my dear, have a great week. Keep safe. Keep cool. Give my best to Scott. And we'll see you next Monday night, right?
Yes.
Okay, and folks, thank you again, everyone. We appreciate you. Thank you, all the moderators. We'll see you back here next Monday night. And in the meantime, keep cool, keep warm, depending where you are. Keep looking to the skies. Send us your questions. I do send them to Claudia, and she does answer them. So send them through, and we'll continue to talk. Okay. All right, folks. Everyone be good. We'll see y'all again real soon.